All right. I'll get number 14 up here for us. Okay, so there we go. So that's y, f of x is the same as y, as you know. Cube root of 6x. So they want us to find out if it's even, odd, or neither. I know I wrote out instructions last time. Let me write them a little better. I wrote them better in the other class. So let me write them because it was my second try. I always do better on my second try. So let me say them better for you now. So to test for even, odd, here's what you should do. Number one, plug in. I mean, it's basically what I said last time, but a little more organized here. So plug in negative x for x. Step 2, simplify. Step 3, compare to original. Compare what you've got now after simplifying to the original. There's there's three possibilities. If it's the same as the original, what does that mean if it's exactly the same after you plug in negative x and simplify? That means it's an even function. What if it is what if it's original? Well, what if the new equals -1 times original? That means odd. And otherwise, because it doesn't have to necessarily be that one of those two. Otherwise, it's neither. So that's basically what I told you, maybe a little cleaner organization. So that's what you need to do. You put that on your 3x5 card. Of course, I say that for everything. But you get that 3x5 card, both sides, write anything you want in there. So basically, we take this function and we put in negative x. So there's step 1. Just simply plug in negative x for x with parentheses, right? Parentheses negative x plugged in for x. Step 2, simplify. Can you simplify that at all? Well, 6 times negative x is just negative 6x, huh? Right, that's just positive times negative. And then, can I do any more? Can I take that negative like out here? Is that true? Is that right? Can you take a negative from the inside of a third root out to the front? Yes? Some say yes, some say no. Some say yes and some say no. What's that? So I'm wondering, is this a legal step? Can you take a negative from the inside of a third root and move it to the front? Is that the same thing to have a negative in the front as it is to have a negative on the inside of a third root? No. Looks like the no's have it. Good thing math is not by democracy, for the answer is yes. So math is ruled by what? Truth, right? There ought to be a word for that. You know, not like oligarchy, but ruled by truth. Anyway, so math is ruled by truth. Let me give you this. Rather than me just handing you, like the old saying, rather than me right now handing you a fish and say, oh yes, it's true, guys, make a note of it, write it down, it's true, you can do that. I mean, it'd be much better if I could show you how to fish than just hand you a single fish. How do you discern that kind of truth? Because a million questions like this are going to come up if you continue to take math classes. I could do you a lot more good if I showed you how you answer for yourself these kinds of questions when all of a sudden you're in the middle of an exam and you're like, oh shoot, can I do that? Can I not? How do you know? I don't remember. How do you figure that out? You don't have to have this ironclad perfect memory. You have to be able to test things. Just test it. What do I mean just test it? Pick numbers and give it a go. So if you're wondering, can you do that? This is what I learned to do somewhere along the way, and it was so helpful to me, so let me try to give it to you. I would just say, well, I don't know, let me take the cube root of something easy and see if it's a negative, and see if it's the same thing as having the negative in the front, because that's the question, right? So how about like -8, is that the same, is it the same as the negative being in the front? Because that's our question, right? I just I don't want x, because when there's x, I mean, who knows, what's x, right? But just do it with numbers. Easy numbers, like cube root of 8. That's something I know. That's 2, right? So you with me? So I'm saying is having the negative, that's kind of scribbly. Can you read what I'm writing there? Having the negative inside, is that the same thing as having the negative outside? So cube root of negative 8 is that the same as negative the cube root of 8? Well, what's this one? Negative 2. Because remember, cube root asks the question, what times itself 3 times is this thing? What times itself 3 times is negative 8? Negative 2 times negative 2 times negative 2 is negative 8. So that's the answer to the cube root of negative 8. What's the answer to this one? Well, the negative here is just sitting in the front. And then what's the cube root of 8? So are the answers the same in the end? So you could move the negative out. See how you do that? So whenever you're wondering something in math and science, the way to move forward in the math science world is not by having this fabulous memory, or I never would have made it. I have terrible memory. I always kid my wife. My wife has a really good memory. We've been married for 25 years now, so she'll remember. I mean, she'll remember, and I don't remember none of it. I mean, this is kind of funny. I always kid her. Like, she'll remember some lunch we went to on some trip we took, you know, and I'll be like, she'll be talking about it, and I'll be like, honey, I don't even remember the trip, let alone, I mean, where we ate lunch on that trip. I always kid her. I said, it's like you're already a widow, honey. Your memories are your own, right? Anyway, so I never would have made it. You don't have to have a great memory. You don't have to memorize all these little things. I mean, there's some memory, of course. But it's about learning to wield the sword of logic well. That's what it's about. It's learning to think and test. That's what math science is all about. So you have a question like this, you go, what if I just put in numbers? Is it the same? So learn to do that. And it's a lot more interesting, too, and a lot easier. All right, so the answer is yes. Bless you. Yes, you can pull that negative to the front. Yes, that's okay. Okay, so what? Where were we? Why were we doing all that? Well, here, so we did step 1, plugged a negative in for x. Step 2 here, we simplified. Step 3, you're supposed to compare this to the original. Right? That's step 3. Compare. How does this compare to the original? Well, it's got a negative in the front. Right? It's got a negative in the front, which means it's negative 1 times the original. It's odd. This is an odd function. Make sense? On that? We good? Questions I can answer? All right, let's move along. All right, try that one. So y equals, whoops, the negative there, huh? Negative 5x plus absolute value of negative 6. So try it out. So go through those 3 steps. Step 1, plug in negative x in for x. Step 2, simplify whatever you can. Step 3, compare to the original. Okay, so how you guys doing? So step 1, plug in negative x. Like that. And then simplify. Step 2, simplify. So 2 negatives, positive 5x. 2 negatives, positive there. Good so far? Okay, then compare. Step 3 is compare. That's not compare. 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 So how does this compare to the original? So there's 2 things. So is it exactly the same as the original? No. It's not the same because there's no negative in the 5x. There is there. Now the absolute value, that doesn't matter, right? The absolute value as far as this negative, we could just get rid of that, huh? Because absolute value negative just comes positive. So that's not a problem. That's not a difference, really. But this one is different, huh? That part is different. So they're not exactly the same. right? So they're not the same. So it's not even. So now, is it odd though? Is it odd? Is it -1 times the original? No, because if you took -1 times this original, what would that be? Let's just do it right here. What's -1 times the -5x plus absolute value -7x? What would that be? That'd be positive 5x minus the absolute value -6, wouldn't it? It would change both sides. It would change that to positive and that to negative, wouldn't it? And that's not what we've done either. We've changed one sign but not the other, right? This is not that. So it's neither. This is a neither case. Does everybody see that? It's neither even nor odd. Neither even nor odd. Because one sign is changed but not the other. Everybody see that second step? You compare this to the original. It's not exactly the same, and it's not like all the signs are opposite either. One of the signs is opposite, but the other's the same. The plus in the middle is the same, but the 5x is opposite. So it's part the same, part opposite. So, no, it's neither. It's not completely the same, it's not completely opposite either. It's part same, part opposite, neither. Good there? Questions on that? Yeah, I hear you. Good question.
I just want to clarify.
Right. Yeah, so Ken, from y equals x squared, I don't remember what I showed and did it, is a graph like that, and that's even, and y equals x cubed is a graph like that, and it's odd because it has, that one has origin symmetry, meaning two quadrant, 180 degree rotation. This is even because it has y-axis symmetry, right? So that's where they get the even odd name, because that's an even power. This is an odd. I know you asked more than that, but let me start there. So this is even, and that has y-axis symmetry. That's odd. But it gets more complex when they put some even stuff, some odd stuff. It's different if they add them or divide them. Yeah, you really do need to use these little check things I gave. Because, you know, I've had students in the past go, oh, no, Mr. Aaron, I got it. I just know if it's even and no, and then they miss it on the test. If there was a simpler rule, I would tell you. I promise. I'm not trying to give you a harder version at all. I spent time thinking about this and boiled it as simple as I can. There's not a simpler way. You can't just look and go, oh, there's even, it's even. If it's just even, yeah, if there's just an x to a power and nothing else added, nothing else subtracted, nothing else multiplied, nothing else divided, okay, yeah, sure. But it's not going to be that simple, right? So if there's other stuff, you really need to do the steps on that. So yeah, that's where they generally get the names, is from that kind of thing, from those powers like that. All right, so we could test this one. Yeah, you want to do this one real quick? Go ahead and test that one real quick. We'll do one more and then we'll move on. We'll have this down very well at this. We go to like 1240, right? Is that what we do? I'm still getting used to this whole thing here. All right. All right, so let me dive in there with you. So plug in negative x for x. And that's going to be what? Positive on the top, right? 4 negative signs all together up there. And positive here. So we get that? Is that good so far? I didn't make any mistakes there. Yeah, looks good. Right, everybody see how I got positive here? Because there's 4 negative signs up top, right? I did it again. All right, so, right? So, now, so how does this compare to the original? Is it exactly the same? No. Right, it's not exactly the same. So not the same. So it's not even, therefore. Okay. But is it the original, which is negative 6x cubed over 7x squared minus 1? Is it the original times negative 1? Will that become that? That's the question, right? If you take the original times negative 1, so those are the two tests, right? Is it the same, exactly the same as the original? That would be even? No. Okay. Well, then is it the original times negative 1? No. So that'll be odd. Is it the original times negative 1?
No.
Yes.
No.
Yes.
It
what does a negative 1 do when you multiply a negative 1? Question is, does it go to the top and the bottom? No. No. That's over 1, huh? Right? So negative times negative, positive, and it doesn't touch the bottom, and yes. So that's an odd, so where to write it? So that's an odd function. Yeah, does everybody see that? Let me say a word about negatives I think that would help in general. Because I kind of said it more simply than it is, and it won't always work quite that way. Basically, when you have when you're multiplying by a negative, a fraction, I should say a fraction by a negative, you can do the top only or the bottom only, but not both, because then you've done nothing. Right? Let me show you. If you take negative 1, I have room up here. I'm running out of room. In fact, yeah, let me just go to a fresh screen. You guys got that copy down? Let's just go here. If I take negative 1 times, I don't know what, 2/3 or whatever. What does that do? You could put the negative on the top only, or you could put the negative on the bottom only, or you could put the negative in the front. Let me say or. It's all the same thing. All those are the same. Top only, bottom only, front only. But it's not right to put it on both. That'd be positive, right? 2 negatives would be positive, wouldn't it? You with me? So when you got a negative going into a fraction, you can put it on the top only or bottom only, right? Because negative over positive or positive over negative, that's negative, isn't it? Or negative in the front, that's negative. They're all a negative 2/3, aren't they? But you can't put it on both, because that would be positive. Everybody good with that? Does that make sense? So you got to be a little kid. Now, what does that mean? What if they have 2x plus 1 over 3x, and I want to multiply it by negative 1? That means you can let that negative 1 go to the top only, because I'd be like negative 1 over 1. Or you can let it go to the bottom, because you can put 1 over negative 1. That's still just negative 1, isn't it? So let it go to the bottom only, but you can't let it go to both, right? So, okay, let's say I let it go to the top. Let me be clear here now with this. How would you let that negative go to the top? What would happen? It would have to hit everybody, right? Minus 2x minus 1 over 3x. Everybody good with that? That's one correct version. So when it goes to the top, if there's more than one item in the top, it has to hit everybody. All right. I think you've got it. Again.
I know, I was doing my last, I almost forgot it today.
All right, so they're giving us the f of x equals, so you got to put that in your graphing calculator into the y1 slot. y1 equals x to the third minus 3x plus 5. And notice they're giving us the x and the y window automatically. They're telling us to do the x window from -2 to +2 and the y window from -4 to +10. So you guys have your calculator, go ahead and do that. Then we'll figure out which of those graphs is the correct one. All right, they're going to ask us, it's this graph, isn't it? And then they're going to say, they're not only going to say, find the max and min. So we found, let me make this graph bigger so we can see it better. It basically, well, I don't need to make it bigger. We'll just use this one. So basically, the answer is C here. And let's find, we found this point. What was this point? Back 1, up 7. And then we found this dot, which was over 1, up 2. No, what was it?
3.
Over 1, up 3? Over 1, up 3. So we found those two dots, this one and this one. Now, what they're going to ask us is they're going to, in parts to come, they're going to say, determine where it's increasing and where it's decreasing. So let's start with increasing. So remember what that is. That's like if you're on the roller coaster, right? And you're saying, okay, I'm cruising on this roller coaster. Where am I going up? Well, I'm going up. It's always as we go from left to right. This section and this section. Right? Those are the sections where we're going up. We're increasing. So what are those sections? And then, by the way, they want intervals in all this. Remember what intervals mean? X with X. They want X's with X's. So what is the X value here? What is the X value here? It's from -2, because the window started at -2, to -1, huh? So it's increasing from -2 to -1, and from what? So I'm not confusing you. Let me try to, this dot here is over 1 up 3. So then this is another increasing interval, and that would be x value to x value over 1 to over 2, huh? Comma, over 1 to over 2. Let me stop there. You guys understanding what I'm saying there? It's asking, where is the thing increasing? I'm saying this part of the curve is going up as we go from left to right, and this part of the curve. And when they ask for intervals, they want x's with x's. So I'm saying x -2 to x -1, and then x +1 to x +2. How I know that is it's +1 at this dot, and the right edge of the whole window is +2. Is that good? And then where's it decreasing? Where's the roller coaster going down?
-1 to 1.
Yeah. From here to here. Yeah, from -1 to +1. X value to x value. Intervals are always x value to x value. Good? So we approximated the local max and the local min. That's this and this. Right? This is the max. This is the min. And then we found where it's increasing and where it's decreasing. All by the graphing calculator. Questions I can answer. That's how all those are going to go. So nobody have a Casio? I'm looking around. I don't see any Casios. It's funny how business goes, huh? You got a Casio? All right. How much? Wasn't it like $50? Or maybe you got it from a friend or something.
No, that's what I bought a while back ago.
Yeah.
I still need to.
Yeah.
I spent like 122.
Okay, so that one's more, huh? Looks fancy, fancier screen. Yeah, there's cheaper ones that are. Anyway, yeah. All right. So all right. So let's go forward then. All right. I remember I was desperately running out of time, trying to do stuff, and I didn't have time for it. All right. Average rate of change of a function. I said that was slope, huh? Whenever you see the words average rate of change, that is slope. Can I give you some logical reasons why that is first, and then we'll crank out the details. Just think real life. What if I took a trip with my family and I put miles on this axis and hours, time, distance and time, which is a common way you'll see physics, take physics, it's almost always often distance versus time, especially in the first physics class. So if I left, this is my house, and I left, and went like that, and then got in the freeway, and then arrived at our friend's house. So say that was my trip, and it took, say, 6 hours, and this is 0 hours, and this is 0 miles, and it went 300. Let's say we had 300 miles, 300-mile trip. Let's say that's our trip, our distance versus time, or miles versus hours trip. Let's say, and so how far did we go? If somebody asked you what was my average speed that I drove on the trip, what would you say? What was my average speed?
50 miles an hour.
Yeah, and how are you coming up with that?
300 divided by 6.
Yeah, 300 miles, right? Because I went from 0 miles to 300 miles, right? 0 at my house to 300 miles at their house. And I did it from 0 hours to 6 hours, so I did it. So it's really 300 minus 0 over 6 minus 0. It's just 300 over 6. So notice I'm doing y2 minus y1 over x2 minus, right? Because this is the point, over 6 up 300. And this is the point, 0, 0. So you see how I'm really doing y2, y1, x2, x1, right? I'm doing slope, aren't I? So I get 300 over 6, which is like you're saying 50 miles per hour. That's a what? A rate. That's a speed. Do you see that average speed or average rate of speed is a slope? You see how that is in the real world? I don't know if you've ever thought about speeds that way. How fast you do anything is always a slope, right? If I say I can grade, or maybe you can solve 10 problems, let's say, per hour. Maybe on MathXL, let's say your average MathXL speed is 10 problems per hour. Think what that is. That's 10 problems per 1 hour. See how that's a slope? It's one thing over another thing, right? That's what it is. So any speed at which you do something, any rate, is always a slope. So that's what you want to realize whenever they say rate, you want to think, oh, slope. All rates are slopes automatically. You'll use that a lot in calculus. That's why I preempt that information. We won't do much more with it in here. But in calculus, you'll go kind of crazy with that whole concept. So it's good just to kind of have it in your mind. And when we're calculating slope, you know what we're doing, guys, getting back to the distance graph? We're really connecting this, whoops, I just did a bad thing, this point to this point. And we're saying, what's the slope of that line? The slope of that line, well, we just did it, right? It's going to be 50. It's the y2 minus y1 over x2 minus x1 is 300 over 6. It's 50. That's the slope of the straight line, connecting my starting point, the house, with my ending point at our friend's house, right? A relative's house, 300 miles away. So that would be as if that's my average, which is what they're talking about, average. That's my average speed. Now, I didn't really drive 50 the whole way, did I? Right? I didn't come out of the driveway at 50 miles an hour. Right? That would be dangerous, right? So I went slowly out of the driveway and around town at 25 and then got on the freeway. That's what all this slow speed is. And then the freeway probably did 65 and 70 and then slowed down again when I got into the relative's town. Right? Everybody seeing that? Is that making sense on that? So average rate of change is if it was a straight line trip, which of course it isn't. In calculus, you'll learn something better than that. You'll learn how to find the instantaneous. You'll say, what was the speed right here? Not just average, overall, start to finish, but what was I doing at 5 hours? How fast exactly? It's the slope of that 1 point. How do you find the slope of only 1 point? Don't you need 2 points? Don't you need y2, y1, x2, x1? How can you find the slope at only one? Because that is your steepness there, right? That's a roller coaster trip, right? And the roller coaster stops right there. That's the angle at which you're facing. That's your slope at that instant, which is your speed at 5 hours exactly. That instantaneous right there. How do you find the slope with only 1 point? Well, I'm not teaching Math 5A. I'm getting excited like I'm going to teach Math 5A. That's for Math 5A. You'll learn how you do that. How you find the slope at only 1 point, the instantaneous slope. That's what calculus is all about. Anyway, we're just doing average. All right, so that was a lot of talk. Let me go back in then. Let's solve. So that's the y. So I just wanted to give you the y. I don't like doing math without reasons. So when they say average rate of change, you think slope. Right? So right away, okay, they just want slope. They just want y2 minus y1 over x2 minus x1. That's what average rate of change always is. How do I do that? Well, the x2, I'm sorry, the x1 is -2, and the x2 is the 0. Those are the x values. Those are the x1, x2. They're giving them to you. So that's the bottom. x2 is 0 minus -2, right? We good with that? And then how do you find y1 and y2? When you plug them in. Yeah, you plug in x1. You plug in -2 to what? To that function. Right? 2x squared plus 1. Plug in -2. I plug in x1. And you get, what is that? Squared up. 4, 8, 9? That's y1. Whoops, supposed to be at the back, huh? That's y1. And then y2, again, plug into 2x squared plus 1. Now I'm going to plug in 0. So that'll be easier. And so what's that, 1? So there we go. What's that, -8 over +2? -4. So that's the slope or the average rate of change. That's how fast that function rises on average. Right? Or it falls, -4. It goes down 4 per unit on average. Good with all that? Question? So y2 came out 1, and y1 came out 9. Yeah, so it's y2 minus y1 over x2 minus x1. We good there? So we did one of these before, so you've kind of seen it again, huh? So let's go on then. All right, well, you guys want to try that? Let's do 22, part A. So in other words, from -9 to -6, find the slope, find the average rate of change. y2 minus y1, x2 minus x1. Give that a try. Did you guys get that okay? So the x, this is x1, x2, so -6 minus -9. And then y1 will, you got to plug in, we got x cubed minus 9x plus 2. So plug in, what was y1? Or what's x1? -9, so -9 cubed minus 9, -9 plus 2. What is that? Somebody got an answer for me there? What is that? That's messy. 729 plus 81, it's like 800 and something. No, that's negative. It's I don't know what it is. Negative 6 something.
Negative 648.
That sounds about right to me. You guys getting that?
Is that right?
It sounds right to me. It's about the ballpark of what I was thinking. Anybody else getting that? Is anybody else getting negative 648 for y1?
No.
Oh,
that
okay.
was just the 729.
Oh, that was just the first part.
Sorry.
Okay, that's okay, yeah. 646, is that the final thing? Okay, great. Sounds good. All right.
Did mess up.
And then the y2 would be same thing, but now we got to plug in whatever x2 was, -6. Right? So we're just plugging in x1 to get y1, x2 to get y2, right? -6 plus 2. -160? Okay. Okay, and we got minus signs from the formula in addition to the negatives that the things come out to be, right? All right, so that's, double negative, positive, you know the whole drill. So what is that, positive 480 something? 80 what? 86, 486. And the bottom is 3. And then you divide those and you get 150 and 162. Thank you. You guys getting that? Matt, okay? That's the slope. Questions on that? We all good? All right. Okay. And what was the answer? 162? All right, 162. All right, so guys, they want you to just type this into your calculator. So 0.5x squared plus 23. You guys have your graphing calculator? This is really an important lesson. So please do this one with me for your own grade's sake on the test. I always put this one on the test. You'll see the practice exam. No secrets with me. There'll be one of these on the test. Basically, it's just type into your graphing calculator. It's just a graphing calculator problem. And find the minimum. That's all it is. Determine the number of line. Yeah, minimize. Minimize. That's all they want you to do. So just type that in. Put that in y1 in your graphing calculator. And then you'll get a graph. And then find the minimum. Find the bottom of it. But the problem is the window. That's the main thing you've got to learn how to deal with on the graphing calculators. So type that into your y1 and then graph it. But the problem is the graph will look kind of weird, and it's hard to get a good picture of the thing. So go ahead and type that in. See what you get. So type that in, and then when you hit graph, what I found was I was working with somebody this morning in my office, and I'd never seen him before. He hit the, what's it called? It's graph fit or something like that. There's on the TI anyway. Is that like the 0 option or something? Is that what it is? Graph fit? No, not the standard. No, it's the. There's a way to fit, because otherwise you see the problem with the graphing calculator is it doesn't. Like I said, they're stupid. They don't know what you want to know. So the problem is the graphing calculator could graph it way over here, and the window's way down here, and you're seeing nothing. Right? It's like looking out the window, and I'd like to see, Mount Everest. Well, it's not going to happen out this window, right? So that's kind of like what the graphing calculator is doing. The window you're looking at, it could be graphing it all above or below your window, and I wish it was a little smarter to tell you that. But I think if you hit the, what is it, graph fit or something? What is it? You guys know what I'm talking about?
Zoom fit.
Zoom fit, that's it. Zoom fit. What is that? Is that option 0?
Yeah.
Yeah, what do you got to hit exactly? So you get the graph, and then you hit second count. Is it under the count menu?
It's just zoom 0.
Oh, you just hit the zoom button?
Yeah.
And then just hit zoom button, and then hit your great. Yeah, so let me write that down for everybody. So graph it, and then hit the zoom button, that's up there. This is for the TI, because that's what most of you have, because they have marketed better, is to hit the zoom button and then hit 0 button. And you should get something that at least shows the graph on the screen. Are you guys getting that? And is it something like that basically kind of shows the thing down here and then back up like that? Is that sort of? Would somebody have a... Oh, no.
I don't know, maybe I did it wrong.
Oh, no, that's okay. Oh, so zoom fit. It doesn't show it come back up. Is that what you guys are getting too?
Make sure I did my thing right.
Yeah.
0.5x squared.
Yeah, it's still... Yeah, that still doesn't work the best, does it? You're not getting this kind of picture, which is what you need to get. Yeah, the window's a problem. So is that what it does when you just type in normal? But what was your window? So I'm trying to get a way to help you get around the window problem, but in the end, the window's a problem. So it doesn't work, huh, with zoom fit? You basically have to focus in on this area. One way or the other, you have to focus in on that area because you got to find that minimum. Now, you might not have anything that looks like that on your screen. Let me help with a couple of things. You want your x min. Well, hold on for a second. What is x on this graph? We want to keep one foot when we're doing math. We want to keep our other foot in reality, in the real world. So what is x? I mean, in the real world, what is x here? X is number of riding lawnmowers. So could x be negative? No. So don't have any negative values on your screen. Let x min be 0. Right? You don't want negatives. And how many could you, what's the max going to be? We're not going to have 10 million of these things. You know, we're only going to have, just go up to like 20 or 100. Go to 100 if you want. You know, just try something. So see, I'm trying to be reasonable. That'll help. And then let your y, now what's y? Let's be real with y for a minute. Keep one foot around. What is y on this one? Now, I don't even see y. Where is y? This is y. Remember, the function is always y. So what is the function? Well, it's c bar x. What is that? A bar, you guys know what a bar means over something? It means average. Bar on something means average. So what is c bar? It's average cost per hour. Could that be negative? No, cost can't be negative, right? So let the y min be 0. You don't want any negative y values either. That's meaningless, right? No connection to the real world. How much do you want the maximum? Well, what's the maximum you think they're going to charge per hour for a riding lawnmower? They're going to charge $1 million an hour for a riding lawnmower? No. They're not going to charge any more than probably, I don't know, $500 an hour, would they? I mean, that'd be a lot. $500 an hour for a riding lawnmower? Not going to go any higher than that, right? Maybe $250. So set up a window that's something like 0 to 100 for x and 0 to 250 for y, and then you'll get a decent graph.
What should you do for the, what is it, x?
The scale? It doesn't matter at all. Don't even worry about scale. Just make the x 0 to 100, make the y 0 to 250, say, hit the graph button again, and you're getting a decent graph now where you can really see a valley where it dips down somewhere. Is that working? You guys getting that? If you're not getting that, make sure you entered your function right.
0, 100.
Make sure this is your function.
Oh, 250, we're changing it to 250.
So we're doing good. Guys, so once you get a decent picture where you can see a valley, then you can do the second calculate, the left, right. Yes.
Something is wrong.
You get in the spot. Is that good? Does that make sense how to do that? So a lot of people miss this one on the test, and I don't want you to miss it. But you got to practice with the window thing. So I mean, the graphing calculators are not, they're not automatic. They're a tool that requires a little bit of skill, and it's almost always about the window. It's about the window. Learning to hone in on the window. Does that make sense? You guys getting that? Can I help in any way? If you're getting some kind of error, it's usually because of the minus sign instead of a negative.
Where is there supposed to be a minus sign instead of a negative? I mean, where is there supposed to be a negative instead of a minus sign?
I think it's just make that mistake.
Oh, your plot thing's on there. We don't do that. So when I would say that plot, I guess you can do it yourself later. See how that plot?
I'm still failing at life right now.
See how that plot's highlighted? Whatever that is, you go Yeah, I'm getting nothing still. You guys getting nothing?
I'm getting nothing.
It's coming out of mine.
Yeah, and then,
How did you do it? Magic.
so that's good, YouTube.
How far did you go? I'm getting nothing on the window.
I've tried typing.
Try 0 to.
Well, it's not even close to 0.
Try 0 to 20 on the X.
I think the Y minimum has to be like 300 and the Y max has to be like 7,000.
Is it that big? Does the Y have to be bigger?
Yeah, that's exactly right.
Because the Y starts much higher than 0.
How high? So make the Y like 1,000.
How did you determine that though?
7,000.
How do you determine
That big?
Yeah, that's how it's on mine.
How'd you find it?
Well, he helped me. I got
Just
after inserted the first one he put up there. We went to Zoom and then Zoom played again. And it showed the graph this time, and then the Windows automatically figured out the window for us. And
so it automatically figured out the window somehow.
yeah.
Is it-
We put 0 to
I
20
put in
and then 0 to
7,000.
50.
Just like you
it's
said.
insane how you put it up on the board and then nothing showed up.
300,
So
Yeah.
then it zoomed it
7,000.
after, and then it showed up.
So you did zoom fit after that.
Yeah.
Okay. Yeah. So maybe put this, the 0 to 20 and 0 to whatever I had, and then hit zoom fit, and then it worked better.
This will show up.
And that's great. Yeah. Okay. Yeah. So just keep trying to change the window and hit zoom fit. Maybe that's the best answer. I don't know, honestly. What I do, okay, if you want to know my method, I just make the window huge. This is what always ends up working. If I don't see anything on the screen, I just go bigger. I just go, look, I don't know where that thing is. It's somewhere out there, and I'm not seeing it. So I go like negative 10,000 to positive 10,000, negative 10,000 to positive 10,000, and then I get a little blip somewhere. And I go, oh, okay, and then I hone in from there. But that takes a lot, that's not always the easiest thing to do. But that's always an option. So if I get a blank window, I just go really, really big. Negative 1,000, positive 1,000, negative 1,000, positive 1,000. Well, I wouldn't do negative because I would look at reality and go, no negatives. So 0 to 1,000, 0 to 1,000. If that doesn't show, I go to 10,000. 0, 10,000, 0, 10,000. Then I get a little blip, right? So let me show you. Well, yeah, here, let me show you. Can I borrow your graphing calculator and I'll show you what I'm talking about. So again, so one more time. So let me show one more time. So if I first graph this, I would go 0. What if I did like 10,000? 0 to 10,000, 0 to 10,000 on my window. Yeah, it's so tiny, it's mixing in over here with the axis, and you can't even see it, right? So I guess there are times when you're not going to see anything. It's just, so 0 to 1,000 on the X, and 0 to 1,000 on the Y. Hit graph, and I see a little blip over on the left, and so that's what makes me realize, okay, change it. That X, I need to scale that X back to 100, go to my window, 0 to 100. So the X is 0 to 100, the Y is 0 to 1,000, and I get a nice little valley. And then how do we find that? We go to second calc, go down to minimum, and the whole deal. Left of it, right of it. Where's my cursor? I don't see anything. So right now I'm not seeing anything on the cursor. So what's up with that? Well, see where my X is? My X is at 45. This goes 0 to 100. So why isn't it on the screen?
Your Y is nowhere.
Your Y
Closer to
is
0.
your Y is in thousands.
Oh, there it is. Oh, yeah, I changed it to 0 to 50. I forgot. I changed that, or 0 to 50. No, I did 0 to 100. But this is only, so I need to keep going left. So there it is. So go further. So this is kind of a pain. This takes some practice. So I'm left of it, enter. I'm right of it, enter. I'm on it, enter. There it is, after all that work. So 9. And they say round to the nearest whole number. So 9 is the answer.
I'm getting 10.5.
Are you?
8.
Same function?
Maybe it's 9.
I don't know what to tell you. So my guess would be, my experience in the past, that you have something typed in wrong on the original function. So double check your y1. That it's really 0.5x squared. You want me to look? 0.5x squared getting a different answer on that. Okay? All right, are we good with that? That's probably a lot of time on the graphing calculator. No, we need to go to something else. All right. Let's. All right. All right, so here we go. Let's do this one. I'm going to do this one quick. They're saying average rate of change. What do you do with average rate of change? Slope. Yeah, y2, y1. So that's, let me bring it down here. That's a slope question. Slope. So y2, y1, x2, x1. Well, what's my x and my y? X, y, x, y. See, the table's just giving them to you. You just use what's right there in the table. What are they saying? 0 to 1.5 for your x. So 1.5 minus 0, right? This is x, this x. And what are the y's that go with the 1.5? Goes 0.19. With the 0 goes 0.08. Make sense? How I just grabbed those right off the table? Everybody seeing that? This is an x1, x2, y1, y2. Right off the table. And then just work it out from there. All right, I'm going to leave it. All right.
I do have my lecture class. I have my math and lecture.
So here we go. So basically we're starting 2-4, and then Thursday will be a really important day. We will, I'll show you a lot about graphing different shapes. But for now, let me just quickly mention, I'll give you the basic 6 that we memorize for graphing purposes. So first off, I'm going to give you this graph, which I think you know. What's the equation of a U-shaped graph? That's x squared, right? And did you know what is the square root, the 2 root of x? What does that one look like? Anybody know that one? Starts in the middle and, whoops, goes like that. I always call it the firework. It looks like a firework you set on the ground, and it shoots off to the right like that.
This is 2.4.
Okay, yeah, no, we're in 2-4 now, and so, bless you. And then let me go to x cubed. Does anybody know what x to the 3rd power looks like? Yeah, it does the snake. And then 3rd root of x. See what I'm doing? I'm going back and forth between powers and roots. So I did 2nd power, 2nd root. 3rd power, 3rd root. What does 3rd root look like? It's a sideways snake. It goes more sideways. See how both of the root graphs go kind of sideways? More sideways than they do up down. And the power graphs go more up or down than they do sideways, right? Because they're more powerful. Okay, so what I'm going to suggest is that you either memorize or write on your 3x5 card these basic 6 graphs I'm going to show you, and then we'll learn how to flip them, how to move them, how to rotate them, how to stretch them, and compress them. So 2 more. Anybody know what does the absolute value of x look like? It's a v, huh? Boom, boom. It's a v graph. And lastly, what does 1 over x look like? Anybody know that one? It's a weird one. It's got some asymptote lines, right? At least if it hasn't been moved. Asymptote lines right through the origin like that. And then it's got one branch here that gets super close to the asymptote lines, and another branch here. It's got diagonal branches. That's called the reciprocal graph, which is the one we're looking at here, isn't it? That's the question. And they're just having you identify for now. So there's the basic 6. You can put those on your 3x5 card for the exam. We'll use those. We'll take those basic 6, and then we'll do all kinds of things to them. And that'll give us the ability to graph a lot of stuff pretty quickly and easily. All right, so these first few questions are just going to be really easy questions about identification. They're going to just give you one of these and say, which one is it? Is it the cube root or the power or the 3rd power, 2nd power? What is it? And you can identify pretty easy. Okay, so this is y equals 8x to the third power. All right, so how do you go about graphing? This will just be a quick introduction. I'll talk a lot more about this on Thursday. We'll go crazy with this. But for now, let me say, what I'm going to encourage you, what I found is easiest for students over the years, I've tried different things. I found this approach much more user-friendly for students. That is, I'm going to encourage you to find just 2 points. We're not going to do tons of points. Just 2 simple dots and a knowledge of what the shape generally looks like. If you just have 2 dots and the general look of the graph, you can always put it together. So first off, what is the general look of x cubed? It's the snake. So we're thinking, all right, this is some kind of snake. Maybe it's been moved or flipped or stretched, whatever. The dots will tell us those particulars. But generally, we know we're looking for a snake graph because it's some kind of an x cubed. We're not exactly sure what that 8 does. Does it move it or stretch it, or we'll see. But the easy way, rather than memorizing all those rules, and I will talk about them on Thursday, but it's easier just to find 2 points. So first off, find the center point and find one other point. So how do you find the center? Where's the middle of that graph? Well, x is 0. Just plug in 0 and see what you get. So when you plug in 0 to that function, y equals 8x cubed, y equals 8 times 0 cubed, you're going to get 0, huh? So 0, 0, there's the first dot. Now, what other point? Let me give you something that'll always work and is super easy. Just add 1. It'll always work except there's one exception, which I'll show you about on Thursday. But 99% of the time, all you need to do is just add 1 to whatever your starting point was. And your first point won't always be 0, 0. I'll explain in harder examples on Thursday. For now, it will be. For now, your first point's always going to pretty much be 0, 0. Add 1, and then plug that in. And that comes out 8, doesn't it? So that's over 1 up 8. 1, 2, 3, 4, 5, 6, 7, 8. Over 1 up 8. So I've got 2 dots on my graph and a general knowledge of what the graph looks like. It's a snake. So it must be doing this, huh? It has to go through this dot and this dot. And it's a snake, so it must be doing that. Good enough. Can you tell which answer it is?
C.
Yeah, it's C, isn't it? Yeah, they have the over 1 up 8 point. And we got it's not multiple choice on the exam next Thursday. It's not multiple choice. It's just show me the graph and give me 2 points. The center point and one other. You'll see it on the practice exam. I say show me the center point and one other point and show me the graph. And all you need to do is put this dot and this dot, show me a snake, have this table, and you're good. It's not multiple choice. Make sense on that? All right, so what did that 8 do? It made it go up 8 times as fast. That 8 was a stretching effect, is what it was. It made it go up 8 times as fast. And this is the one that's more helpful to people. Okay. So on number 10, what they're asking us is to plug things into functions. This is what we call a piecewise function, which means it's a couple of functions put together in different areas. Notice what it says about the x's here. It says when x is between -2 and +2, you're supposed to plug into 2x minus 1. But if x is between 2 and 3, you're supposed to plug into that function, x cubed minus 2, right? So part A is asking me, what's f of 0? What's f of 0? So when x is 0, which function am I supposed to plug into? The top one. Does everybody see that? Because that x, that 0, is between -2 and +2, isn't it? It fits this condition, huh? So in that case, you're supposed to plug into 2x minus 1. So 2 times 0 minus 1, was that -1? Does that make sense, what I just did there? So whenever they give you a question like f of 0, what's the next one going to be? F of 1. You've got to decide which of the 2 functions do I plug into. Well, if x is 1, which function am I going to plug into? The top one or the bottom one? Top one again. because that value of 1 is also between negative 2 and positive 2. So you plug into 2x minus 1 again. And that comes out positive 1, huh? Now the next question is going to be f of 2. So f of 2, which function do I plug into? Barely the top. Still the top. Because the top includes the 2, less than or equal, whereas the bottom just says greater than 2. Not 2 right on the money, right? So 2 is, that x value of 2 is between negative 2 and positive 2, including the 2. So it's still the top one. So 2 times 2 minus 1, 4 minus 1, 3. And then lastly, they ask what's f of 3. Now which function? I'm going to plug into the bottom one now, huh? Because 3, x value of 3 is between 2 and 3, including the 3. So plug into the top one, which is the bottom one, sorry, which is x cubed minus 2. And so that's what? 3 cubed minus 2, which is 27 minus 2, 25. So we good there? So it's all about figuring out which function you're going to plug into. We're going to go heavier on this next problem. We're going to graph that way too. So everybody getting the main idea. And a function given to you in pieces, piecewise function, you've got to realize which one to plug into for which x values, right? That good? All right. Let's go to the So number 12. So it's in pieces. It says when x is less than 1, use the plug into negative 2x plus 3. But if x is greater than or equal to 1, plug into 2x minus 1. And it asks you a bunch of questions, domain, intercepts, blah, blah, blah. It's all graph. It really is. In the end, if you get the graph, all those questions are cake. They're super easy. If you just get the graph. So it's all about getting our hands on the graph. And on the next exam, the exam next Thursday, 9 days from now, I'll just ask you for the graph. I'll just give you piecewise. You can see it on the practice exam. There'll be a piecewise graph, and I'll just say, hey, just draw me the graph. Because I know if you can do the graph, you can answer anything. So let's make the graph. So the graph is going to be all about what's happening at positive 1. So let's go to positive 1 right here. And I'm going to put a wall. You don't have to do this. There's not really an asymptote line or anything. I'm just doing that for visual effect to help you realize what's going on. Do you see the x-axis at over 1 is where the whole story separates? In other words, in this section, when x is less than 1, I'm supposed to plug into negative 2x plus 3, huh? And in this section, to the right of the wall, when x is greater than or equal to 1, I'm supposed to plug into 2x minus 1, the function says. See what we're saying? So it's like we're going to have two different graphs, and they're going to connect up at that dotted line, huh? And that dotted line's not really there. I mean, I'm just doing it to help you guys see visually. But that's the deal. Does that make sense? So you just form two graphs. Now, let's do the left one. Let's start with this area. And so that'll be y. Remember, f is just y. So I'm gonna do the negative 2x plus 3 graph, the left side. I'm gonna make a table. What I suggest is just make a simple table and find 2 dots. That's all you need. Just find 2 dots. So okay, now what x value should I plug in?
0.
Yeah, 0 would be a good idea, right? Why is there that line there? Yeah, you guys are totally right. Let's basically plug in anything to the left of 1. So, here's 0. Oh, that was the axis, wasn't it? That's what that was. Like, what is that thing? That's the axis. Yeah, so there's 0. So plug in 0 would be a good one, and also 1 would be a good one. Now, I know you might be thinking, wait a minute, not 1, Mr. Heron. It said x is less than 1, less than 1. Yeah, I know. So I can't do 1. I'll circle 1 to remind myself It's not right on the money 1, but you know it does get infinitesimally close to 1. You want to make sure you're not thinking whole numberish. It's not just like there's 0 and there's 1 and there's nothing in between. No. There's half and, there's all kinds of numbers between 0 and 1, right? So our graph, the left portion of the graph, is going to get infinitesimally close to this line. For example, 0.999999, which is almost 1. It'll virtually get to 1, but not right quite on the money. So I need to find out what happens when x is 1, but there'll be an open dot there. That's why I'm circling the 1 to remind myself this is only true for values not less than or equal to, less than 1. So let's plug in 0. What do we get? Minus 2 times 0 plus 3. Is that 3? Let's plug in 1. What do we get? Minus 2 plus positive 1. But circle that, because again, that's an open dot point, because it doesn't quite hit that dot, but it gets infinitesimally close, so we still need to see it. So let's do those dots. Over 0 up 3. Solid dot. Just did that one. Now, over 1 up 1. Open dot. Right there. Everybody seeing those? That's 1, 1. There's over 0 up 3. And we're going to connect those. This graph, it's a straight line, isn't it? How do I know that's going to be a straight line, that graph? Yeah, x it's just first power. We just have x to the first power, no second powers or anything. It's just a straight line, so it must go like that, right?
So you don't actually plot the 1, 1. You're just like circling it.
Yeah, so it's an open dot, because it doesn't quite hit there. It gets infinitesimally close to that point, but doesn't quite make it all the way. So that's an open dot, because this was only for values of x less than 1. The mistake a lot of students make is they go, oh, I'm just supposed to do stuff less than 1, I'll start at 0. That's thinking whole numberish. You need to break that kind of thinking. There's a zillion numbers between 0 and 1. We need to find out what they're doing, right? Does that make sense? So you want to actually do the 1, even though you can't do the 1 right on. You want to do the 1 on your graph and circle it, because it gets infinitesimally close to that 1, 1 dot. So that's the left side. Let's go over here now and graph the right side. So another xy table. For the right side, I'm using y equals 2x minus 1. And what are some values? I just need 2 dots. I want to plug in 1 because I want to get what it's doing right at the wall. You always want to get what it's doing right at the wall of separation. Right? Greater than or equal to 1. So how about just 1 and 2? I would never put 0 into this. This is the kind of mistakes I see people making on the test. Why would I never put 0 into that? Into this table on the right. Yeah, it's only stuff greater than 1. Greater than or equal to 1. 0's over there. Right? You only plug into the table, the function, the things it says you can put in. Right? Does that make sense? You can only put in things greater than or equal to 1. So put in 1, what do you get? 2 times 1 minus 1, what's that, 1? And put in 2, 4 minus 1, 3. I'm not going to put in 0. So over 1, up 1, notice it fills in the other open dot. That does not always happen. I wish they didn't do that. They always do that in the first problem. That's not typical. Normally that won't happen. Over 2, up 3, here's the other dot. Connect the dots, straight line, there's our graph. It almost looks like a V in the end. We are done.
Not supposed to continue that line. It's not like a full line. Or...
Yeah, no. It's the red line, for example. Yeah, the red line stops at the mid, and the black line stops at the mid.
Okay.
Because that's what the restrictions say, right? Greater than or equal to 1 for the one on the right, only less than 1 for the one on the left. Yeah. The mistake on the test is I'll see people let these lines continue through. I take off quite a bit for that. You might think, see, that's where I'm totally easy if you just add wrong, subtract wrong, little silly stuff. I might even give you full credit with the wrong answer because you just added wrong, but you knew what you were doing. That's what I care about. But if you do something like that, like continue those lines, I go, they don't really get it. They don't really understand that the thing's supposed to stop. That's the big idea here. So it makes sense? So make sure you're getting that. That's just so you know, no surprises. I'm into concepts because that's really what's going to make you succeed in calculus. You know, everybody makes adding mistakes. I'll do it all the time too. I mean, that happens. But concepts are what really matter. You get that idea? So, it has to stop at that wall there. That makes sense on that? That good? And that whole, like, it was kind of weird, huh? The way the other one's solid dot filled in the left one's hollow dot. So in the end, there's like nothing special there. It's just a normal dot. That's not typical. That's weird. Usually you'll have like one of them hit with an open dot and the other one has a solid dot and they're just disconnected like that. That's more typical. There's totally a jump usually between the two. They just made a weird one here. Is that good on that? Remember, Mr. Heron, what happens at the end? Every day you forget what happens at the end. All right, so here we go. They want us to work backwards. These are hard. They want us to work backwards from a graph to an equation. That's kind of tricky. So I want to take this left piece, for example, and write its equation. And then I'll do the right piece. And they're in two. One of them's the left, one of them's the right. They're separate. All right. How do you know which is which? Well, this one is left. This one is right. How do I know? It says x greater. So that's got to be to the right. Greater stuff is to the right. The right of where? Where's the wall of separation? It's right here at 0, isn't it? Right there at x is 0. At x is 0 is where you go from the left graph to the right graph. So this is greater than or equal to 0. I can fill that one in. And this is less than 0. So I can fill in those boxes. The wall happens at 0. Good to there? So the wall's at 0. Okay. And now, what is the function, though? What is the left function? What's this? Okay, what's that? How do you get the... Basically, I have to look at that picture and come up with the equation. Let me blow it up a little bit. It's going from... I circled it and I can't see now. It's going from minus 1, 1. Looks like. Right there. Minus 1, 1. And, minus 2, 0. And there, huh? Even though that's open dot, that's what it's doing, right? I'm just blowing up that left side so we can see it clearly. It's a little piece of a line, isn't it? So its equation must be mx plus b, because it's a little piece of a line. You with me? Do you remember from your algebra days how to work backwards from a graph to an equation? That's not easy. What's the slope, first off? What's the m? Can you tell what the m is? Rise, run. What's the rise? Up 2, over 2. Slope's going to be 1. And now I need b. Good so far?
When we're drawing in our graphs, you want us to use the open dots, correct? When it's not.
Yeah, on this one, the graph doesn't matter because they gave me the graph.
Okay.
So that open dot doesn't matter to me at all. Yeah, but if we're producing the graph, we have to show open dots that are open dots. But as far as I'm just coming up with equations, I don't care about that open dot at all. All right, so everybody good at how I got the slope there? Slope is rise over run. 2 up 2 over 2. Right? 2 over 2. Now, what's the b? The y-intercept. What's the y-intercept? No, it's 2. It's where it hits the y-axis, huh? The b is 2. 1x plus 2. Everybody seeing that? So it's 1x plus 2. That's the left equation. Everybody good with that? This is 1x, or just x, plus 2. Good? We're running out of time. Let's do the right one and we'll stop. So how do you do it? Let's do the right one now. How do you do the one that's on the right? Well, he's here. He goes there. He's got the point, what, over 1, up 1? That dot right there. Over 1, up 1. So what's his equation? Yeah. So mx plus b. What's the slope? Up 1 over 1. 1 over 1, x plus b. What's the y-intercept? Where does it hit the y-axis? At a height of 0. X plus 0, or just x. So this one is y equals x. Does that make sense how we did that? mx plus b. All right, let's do this. Let's stop there.